Welcome to this session on control of wind turbines and wind power plants. My name is Paul Sørensen and I'm professor in wind power integration and control. The learning objectives of this session are, first, to understand what are actually the objectives of controlling a wind turbine. And secondly, we will dig a little into the difference between pitch control and active stall control. And next, we will explain the maximum power point tracking. And finally, we will understand the control architecture of a wind power plant at an overall level. So, what are the objectives of controlling a wind turbine? Well, first of all, we want to have optimal power production, which means that if the wind speed is lower than a certain nominal value, then we want to produce as much power as possible. And secondly, we want to limit also the power to the rated value of the wind turbine, which is seen here in red. So that brings us actually to the next objective, that we want to reduce the mechanical loads on the wind turbine. And besides reducing the power, there are also issues like we need to be sure that we are damping the oscillations that we can have on the drivetrain, and also we need to control the yaw angle so that the wind turbine always points into up to the wind. And there can be mentioned several other points here in reducing mechanical loads. Another group of objectives for control is to comply with the requirements from the grid side, and they are becoming more and more important in the control. And this is, among others, it is to be able to control active and reactive power so that we can support the frequency and the voltage in the grid. Also to respond in a stable way when there are disturbances in the grid. This is called fault right through. And also to ensure that the power quality that we get out from the wind turbine and wind power plants is good. This can be a harmonic emission from the wind turbines, and it can also be flicker emission. And then it's also a control objective to mitigate the other disturbances like noise, and also possibly shadow flicker when blades are passing the sun. There can be a few periods where it is smart to stop wind turbines. So, blade angle control. This is where we are going to talk about the difference between pitch control and active stall control. Both of them are controlling the angle of the blade, but one is controlling to one side up in the wind. This is the pitch control, and the active stall control is controlling out of the wind. Now we see here the graph shows for different pitch angles on the blade how the power will vary output depending on the wind speed. And what we see is if we are in the area where we want to limit the power, then having a small change in the wind speed can give us a very high change in the power, which means that we need to have a very fast control in order to avoid to have too high torques. And this is the aerodynamic torque that we have coming in on the wind turbine drivetrain. And the way that this is handled is first by having a fast pitch control that is necessary, but in the first place it is handled by having variable speed so that the additional aerodynamic power is actually accumulated into or converted into kinetic energy and thereby not really transmitted through the drivetrain. So this concept of pitch control, it has been used for smaller fixed speed wind turbines, but today it is only used for variable speed wind turbines because otherwise the drivetrain will be very heavily loaded. If we have fixed speed wind turbines, then active stall control can be used instead. And here we are turning the blade in the negative direction, as you can see from the values of the pitch angle. And what we see here is when we are limiting the power to the nominal value here, and at high wind speeds the slope is not at all as high as over here, and this means that the torques that we will see when the wind speed is fluctuating, the torque changes are much smaller in this case. So that is why this concept can work with fixed speed wind turbines and also with relatively slow blade angle control, meaning that the blade angle actuators and the whole pitching system can be much cheaper. So this has been applied in fixed speed wind turbines. Now to the point of tracking the maximum possible power, the power generation, and to understand this we can use the power equation that we have here, where the power we can see it's from a wind turbine is giving as the air density multiplied by the swept area of the wind turbine and the cube of the wind speed. This is actually the energy, that is the kinetic energy we have in the wind. Then we are multiplying this with a power coefficient, which is then actually an aerodynamic efficiency. And we can see that the power coefficient, it depends on the pitch angle. It also depends on the tip speed ratio. And the tip speed ratio, it's the ratio between the speed of the tip of the blades to wind speed. Now the point is that we can see easily from the power equation we want to have as high a CP as possible, and in order to do that we should stay on the top of this curve, which means that we can keep the pitch angle constant, but we need to change the rotor speed so that it follows the changes that we have in the wind speed. So increasing the wind speed means that we should also increase the rotor speed. So that is the target of doing maximum power point tracking, to follow the changes in the wind speed. Now to the architecture of a wind power plant. What we have here is that we have a central controller in the wind power plant, which is communicating reference values and receiving back status from the wind turbines, and also taking measurements from the point of connection to see that we are supplying what we are supposed to supply to the grid here in the point of connection. And the access from the operator to the wind power plant is going directly to the wind power plant controller, which is then automatically taking care of communicating further down to the individual wind turbines. To summarize, what we have talked about and what we have learned today is to understand the main objectives of controlling wind turbines, to be able to distinguish between pitch control and active control, and understand which of those that are most suitable, and also the basic principles of maximum power point tracking of a wind turbine, and finally the architecture of a wind power plant controller.